All right. So, hello and welcome everyone to week 2 of interactive live sessions for the course on Computational Fluid Dynamics for Incompressible Flows. It is being instructed by Professor Amaresh Dalal from the Mechanical Department of Mechanical Engineering in IIT Guwahati. I am the teaching assistant for this course. My name is Debjit. I am currently a PhD scholar in IIT Madras, and like every other week, we will be solving some tutorial problems together. So, without further ado, let us begin. So, today our topic of discussion is confined to classification of different kind of partial differential equations which we come across in CFD. So this is a very simple question number 1. I will be sharing the poll with you guys. Once you read the question and figure out the correct solution, you can put in your responses in the poll. If you are anyhow unable to access the poll, okay, we will figure it out. So if we come back to our question, which is question number 1 of today's session, which says which of these is not a type of PDE or partial differential equation based on their mathematical classification? Is it option A circular? Is it option B elliptic? Is it option C parabolic? Or is it option D hyperbolic? So take your time, read the question carefully, and once you figure out the solution, put in your response in the poll. I would discourage people from using the chat box because since everyone is trying to solve, if they see the question, then that takes away the honesty with which they try to solve the rest of the question, right? So please try to use the poll to put in your responses. And whenever you have any doubt or any kind of question in mind, please do not hesitate to ask. These are interactive sessions, so they should be as interactive as possible. So these sessions won't in any way be more informative than the lectures, right? The lectures would have more information, obviously, but these sessions are important because of the two-way communication that allows it between us. So let's make sure that we utilize it. So any kind of doubts, anything, if you are unable to answer any part of the question, if you are unable to understand, how to approach the question, do ask. And uh, if you have something in mind which is not at all related to the question at hand, then also please do ask. Okay, no need to hesitate. All right, so I don't see any responses in the poll, but there are a few responses in the chat box, and they are in favor of option A. So let us see what is the correct answer. The correct answer indeed is option A. So why is it? So first of all, let us look at the different kinds of classifications of PDEs which we learned. So there are basically two families of classification. What are they? Can anyone tell? You can unmute and answer, or you can type in the chat box as well. However you feel comfortable, it's up to you. So there are two ways of classification. What are they? Can anyone answer? Okay. So the one of the two ways are a physical way of classification, and the other is a mathematical way of classification. Now, within physical, there are two categories. This time, can anyone say what are they? I mean, please don't feel shy to answer. Like, what if I'm wrong? It's okay to be wrong right now. Okay, but it's important to
Uh,
try. Yes.
well, in the physical classification, there are, I think, equilibrium problems are there and marching problems
Correct.
and I think initial value problems are there. I think in physical classification,
Correct.
whereas in case of mathematical classification, there are hyperbolic, parabolic, and elliptical type of PDEs basically.
Correct. Absolutely correct. So in physical type of classification, there are two major categories. One is equilibrium and other one is marching. Now, marching is often called time marching because most commonly it is the the independent variable time is the one in which the domain marches. But anyway, there are examples where it marches in other spatial directions also. It doesn't have to be time. It's more commonly time. That's all. Now, in case of mathematical classification, we can see the categories within the options of our question itself. So they are elliptic, parabolic, and hyperbolic. Right. So this is how we can majorly classify different partial differential equations. And why is classification even necessary? It's necessary because you'll see later that we approach different schemes towards solving them. Or even if we leave that out, even if we forget about CFD and think about partial differential equations and their solution only, then also different kinds of equations, different classes of equations have different approaches of solving them. So, what does it matter to us while we are learning a CFD course? In CFD, there are multiple schemes of solving, of first of all discretizing and then solving. So, those schemes, the choice of those schemes would depend on the type of the problem at hand, and that can be very systematically classified in this way. So these are the if we know the type of the partial differential equations which are involved in our problem, then we can choose appropriate schemes to attack them and finally get a solution out of them, an appropriate solution out of them, right? So that's why classification is important. Okay. If there are any questions you can ask, otherwise we will move on to the next question. Okay. So we'll move on to question number 2 of today's session, which says that in order to solve time marching problems, we require which of the following? Is it option A, boundary conditions? Is it option B, initial conditions? Is it option C, all of the above? Or is it option D, none of the above? The poll is live. Among the four options A, B, C, and D, you can pick any one and put in your response in the poll. But first, read the question carefully and try to figure out the correct option. So, in order to solve time marching problems, what do we require? Do we require boundary conditions? Do we require initial conditions? Do we require all of the above? So, here it's a bit tricky. So, all of the above means just A and B, and none of the above means none of them, A, B, nor C. Right? So, this is something to take into your consideration. So in order to solve time marching problems, we require which of the following? Is it option A, boundary conditions only? Is it option B, initial conditions only? Is it option C, all of the above? Or is it option D, none of the above? I can see one response in the poll. What about others? I request everyone to participate in this. Whatever you think, like there is no wrong answer here, or casting a wrong answer won't mean anything. It's better to make the mistakes now rather than to go in an exam or in an assignment, then you give a wrong answer. It's better to clear things up right now while we are practicing things.
Well, I think it's both initial and boundary conditions.
It's option C, right?
Yes.
Okay, so let's have a look at the correct answer, and it is indeed answer C, option C, all of the above. So all of the above basically means initial conditions and boundary conditions both are required. So how it works basically, so in equilibrium kind of problems, so their equilibrium problems are basically steady state problems mostly. And mathematically, these are what? Can anyone say what kind of equations are generally equilibrium problems? I mean, according to mathematical classification, are they elliptic, parabolic, or hyperbolic? Any guesses?
Parabolic.
No, these are basically elliptic equations. And time marching problems. These are either unsteady problems or marching in one direction. So time marching means unsteady only, and these are basically characterized by either hyperbolic or parabolic type of equations. Correct. So what happens in equilibrium type of problems is that, let's say there is a domain. I'm taking a 2D domain, for example. This is you know x and y, and these are boundary 1, boundary 2, boundary 3, and boundary 4. It's enclosed by 4 boundaries, as you can see in the figure. So what's basically done is the boundary conditions at all these 4 boundaries are given, and then we try to solve for the steady state. Like if we left this system as it is after infinite time, what would be the state that this system would be in? And they usually approach towards one equilibrium only. Let's say if you're trying to solve for temperature within this domain, in the most general case, this temperature is a function of x, y, and t, right? Space and time, all of them. But the solution that we are looking for, the excuse me, the solution that we're looking for, the steady state solution, what would be the temperature as t tends to infinity? This is actually a function of x and y only, and not of time. So this is what we actually solve for in equilibrium problems. But let's say a different case where we have a similar, two-dimensional domain, and this is x, this is y, and there are these all boundaries. And at t equal to 0, I give some initial conditions, like let's say t x y 0. I know that this is some function of x and y. I know this. I know all the uh, values of t within this particular domain when time is equal to 0. And in addition to all this, there are boundary conditions given at the 4 boundaries as well. We learned about different kinds of boundary conditions in the previous week. It could be, a Dirichlet type boundary condition, Neumann type, or mixed, or Cauchy-Riemann, or Cauchy type, or Robin type. So there are various types of boundary conditions which are possible. But anyway, we give this initial condition as well as the boundary conditions, and then we try to find out what would be txy at a particular time t. And unsteady problems basically change with time. So this solution t is actually a function of all of these, of spatial variables x and y as well as the temporal variable t. Got it? So these are basically the format of the solutions that we expect while solving these different kinds of questions. Does this make things clear? Okay. So I'll end the poll. Any questions from your side? Any questions or doubts or anything? If you need any clarification, you can ask. Nothing? Okay. So we will move on to question number 3 of today's session, which says to mathematically classify partial differential equations, coefficients of which terms of the equation should be considered? Is it option A, terms of the highest degree? Is it option B, terms of the lowest degree? Is it option C, terms of the highest order? Or is it option D, terms of the lowest order? So once again, the poll is live. So if you have read the question carefully and figured out the correct solution, you can put in your responses in the poll. Okay, no need to hurry. Take your time. Figure out the correct solution. That is important. So in order to mathematically classify PDEs or partial differential equations, coefficients of which terms of the equation should be considered? Those of the highest degree, those of the lowest degree, those of the highest order, or those of the lowest order.
So the one with the highest order.
Sorry, can you repeat again? I couldn't hear you.
The one with higher order, sir, like
Oh,
option
sorry,
C, I guess.
option C. Okay. So in the poll also we have a few responses in favor of option C, and if you look at the correct solution, it is indeed option C. So it's the terms of the highest order which should be considered while mathematically trying to classify PDEs. So as we saw in the most general case, so what is the most general case? A dou to P dou x square plus B dou to P dou x dou y plus C dou to C dou y square plus D dou P dou x E dou P dou y equal to sum f, or we can keep it this side only, plus sum f equal to 0. This was the most general case, right? So there in mathematically classifying the PDs, only the terms of the highest order are to be considered. So in this equation, uh, these two terms are in the first order and all these are in the second order. So only these three terms we will consider for mathematically classifying the PDEs, right? So let's say if it was something of a higher order, uh, the equations are like this. So uxxt minus uxx equal to some alpha uxtt. So you know this notation, right? So ux means the derivative of x, derivative of u with respect to x. And if I repeat that, that means repeated differentials are taken. So it's like this mixed derivative. So this one I can write as phi xy, phi suffix xy. So here also u suffix xxt means dou 3 u, dou 2 x, and dou t, right? So this basically means dou 3u, dou 2x, dou t. Similarly, all these also. So in this case, which terms will be considered for determining its classification, mathematical classification? Which terms do we need to consider for this equation if we want to mathematically classify it? Any guesses? You can type in the chat box or you can unmute and answer. It's up to you. However you feel comfortable. So here we have to pick out the terms of the highest order. What is the highest order in this equation? Is it 1, 2, 3? What? So if we look at the orders of the individual terms, this is order 3, this is order 2, this is order 3. So 3 is the highest order, right? Correct me if I'm wrong. Right. So for classifying the PDs, this term and this term, only these two would be used. And we will leave out this one since it's not of the highest order. Okay. Any questions on this? Any doubts? All right. So if there are no questions, we'll move on to my questions. Question number 4 of today's session, which says match the following. So there are two columns. Different kinds of equations are there in the first column, and in the second column, the classifications of PDEs are given. So you have to match the exact equation with its type. So yes, someone has raised their hand. You can unmute and ask. Vishal Poddar, do you have a question? You raised your
Three.
hand.
D. It's D, I think.
Your answer for this question is
No. Yeah. It's C. C. Not D. Sorry.
okay. Okay. We'll see. Let's let others also have a look at the question and put in their answers. The poll is live. You can always put in your response in the poll. So the in the first column there is option A 2D steady state heat conduction equation, option B 1D unsteady heat conduction equation. There is option C second order wave equation. And in the right hand column we have parabolic, elliptic or hyperbolic. So these are mathematical classifications of the PDEs, and the PDEs representing whatever physical problem is given in the left column. So try to figure out the correct combination and then see if the correct combination is present within the options. So there in the options we have option A, A1, B2, C3. Then we have A3, B2, C1. Then we have A1, B3, C2. And lastly we have A2, B1 and C3. Okay, so now you're changing your answer to option D. Okay. There is one other answer in the chat box as well in favor of option D. Anyway, take your time. Do this carefully. There is one response in the poll as well. I'm hoping some more responses over there. So let's see if we can remember each of these equations. So option A, 2D heat conduction, steady state heat conduction equation. Can anyone help me with this? What is the equation? Steady state heat conduction equation in 2 dimensions. What is it? How do we write that? Please help me out, guys. I've forgotten it. No one to help? Okay, so I'll start doing it myself. So basically, the 2D steady state heat conduction equation looks something like this. So if x and y are my two coordinates and T is the temperature, then this is how it looks like. Correct? Am I wrong? Anyone? Correct me if I'm wrong. I may be wrong. So the second equation, 1D unsteady heat conduction equation. How to do this? How does it look like? Yes, you. If you have anything to say, you can always unmute and ask. No need to raise hands. Vishal Poddar and Krishna Goda, you have your hands raised. You can voice your concerns or doubts or anything without any hesitation. No need to raise your hand. Anyway, so back to this 1D unsteady heat conduction equation. So unsteady means there will be a dot t, right? There will be a time derivative. What else?
Equal to alpha del square t by del x square.
Alpha del square t by del x. Correct. Then we have, okay, I'll write this a bit differently. I will write this as minus this and equal to 0. Okay. Then if we go to option C, second order wave equation, how does this look like? So we have a double derivative with respect to time.
Yes. Is equal to c square del square u by del x square.
Correct. So this also I will rewrite like this. So now we have to classify these equations into parabolic, elliptic, and hyperbolic. So what is this first equation? Option A.
Elliptic.
Elliptic. So any kind of this these there is a kind of this equation. Do you know what it is? It's called the Laplace equation. And if it was inhomogeneous, so if it's homogeneous, it's called a Laplace equation. It was if it was inhomogeneous, then we would have called it a Poisson. Yeah, tell me. Does anyone want to say anything? So now let's come to option B, this 1D heat diffusion equation. What is this? Parabolic, elliptic, or hyperbolic?
Parabolic.
Parabolic. Correct. And this wave equation, there is only one option left, hyperbolic. So basically, the correct answer should be A2, B1, and C3, right? So A2, B1, C3. Option D should be the correct one. Let's look at the correct answer, and indeed, option D is the one. Okay. Any questions regarding this? No, right? Okay. So we will move on. We'll move on to question number 5 of today's session, which says classify the following equation. What equation do we have here? 1 minus m infinity square into dou 2 phi dou x square plus dou 2 phi dou y square equal to 0. So this is the incompressible flow equation. So we have to classify this as hyperbolic, elliptic, parabolic, or any of the above. So which one should it be? The poll is live. So try to look at the equation carefully and figure out how you would classify it. And once you have figured it out, you can put in your response in the poll. Or, unmute and answer, or type in the chat box. We are open to anything, right? But getting the solution right is the most important. So how would we approach this? So first of all, if we compare this with the general equation, so plus c dou 2 t dou y square plus rest of the terms I'm writing as h equal to 0. So if we compare with this, what do we have? We have a equal to 1 minus m infinity square, we have b equal to 0, and we have c equal to 1. Correct? Then how do we proceed? How do we determine?
Uh, so if m equal to 1, it's is it parabolic? If m
Yes.
equal to 1,
So you're saying parabolic, right?
and if m equal to 0, it's elliptic.
Okay. So let's have a look. First of all, how do we classify any equation from here? We have the values of a, b, and c. How do we go for
B square minus 4ac.
b square minus 4ac? Try to fix that out. So in this case,
Yes.
it's 0 square minus 4 into 1 minus m infinity square into 1. So this basically boils down to minus 4, 1 minus m infinity square, right? So we know that, so for different values of m infinity, these would be different. So if m is 0, what would it be? So let's make a small chart over here.
Minus 4.
So we have m infinity here and b square minus 4ac here. So if m infinity is 0, it would be minus 4. This being negative means the type of equation would be what?
Elliptic.
Mhm. Now, if m was between 0 and 1, what would it be then? If m is a positive value but less than 1, so 1 minus m square would still give us a positive value.
Negative.
And that would mean that this would be a negative value.
Yes.
Would be
And
something less
it
than
will be elliptic.
0. Less than 0. So in this case also it would be elliptic, right?
Yes.
Now, okay, I started this at the very bottom. Now I'm starting to regret it. But anyway, we'll try to move this deal over here. So we covered 0 and from 0 to 1. Now let us consider if m is greater than 1. What happens in that case? So m is greater than 1, 1 minus m squared. This becomes a negative value, and negative multiplied by negative becomes a positive value. So this becomes greater than 0. Okay, no, there is one more case in between where m infinity is exactly equal to 1. What happens in that case? This becomes 0, right? So what happens if this is equal to 0?
Parabolic.
And then we have our last option where m infinity is greater than 1. In that case, 1 minus m squared, this value becomes a negative value, and negative multiplied by negative is positive. So here this is greater than 0. And as a result, this would be hyperbolic, right? So if we come back to the question, classify the following equation. It could be hyperbolic, elliptic, or parabolic, any of the above. So option D should be the correct answer. So if we look at the correct answer, it is indeed option D. Right? Any questions on this? Why is it any of the above and not, any one thing in particular? Okay, so if there are no questions, we will move on. We'll move on to question number 6, which is classify the trichomy equation. So here also we have those same options: hyperbolic, elliptic, parabolic, or any of the above. So how to classify the trichomy equation? Once again, the poll is live. Once you figure out the solution, put in your response in the poll. So how does the trichomy equation look like? Trichomy equation, anyone?
Is it like the wave equation? Is it similar to the wave? No, it's del square u by del x square minus x. I think del square u by del y square equal to 0.
Del square u by del x square
Minus x into del square u by del y square equal to 0.
minus x del square u by del y square.
Equal to 0.
This is what you're saying, right?
Yes.
So this is indeed one way of writing the trichotomy equation. You can fix the dependency and still get the form of the trichotomy. This is also another way of writing this. So what is it? Hyperbolic, parabolic, or elliptic? So basically these classes of equations are called trichotomy equations. Instead of minus, you could have plus as well. So you could do this as well. This would still be a trichotomy equation. Same thing goes here. Sorry. So all these four forms are valid. You can take any one and try to approach the answer. So is it hyperbolic, is it elliptic or parabolic, or option D, any of the above? Forget about all this, consider only one. Let's say we will consider the first one only. Minus x into dou to u dou y square equal to 0. So focus on this equation and try to mathematically classify into either hyperbolic, elliptic or parabolic. Okay, we don't have
Where
any responses in the poll. In the chat box, someone is saying T.
a equal to 1, b equal to 0, and c equal to minus x, then we'll go for b square minus 4ac will be equal to 4x. Then again, if x equal to 0, then b square minus 4ac is equal to 0, which is parabolic. And if x equal to 1, it will be greater than 0, that is up to 4. It will be hyperbolic. And if it is x equal to minus 1, then it will be elliptic.
Correct. So let me try to do what you just said. So you said A is 1, B is 0, and C is minus x, correct? Then if we try to figure out what is b square minus 4ac, we will get 0 square minus 4 into 1 into minus x. So basically 4x, correct? So if x equal to 0, b square minus 4ac is also, sorry, not equal to, greater than 0, then this is also greater than 0. In that case, it is hyperbolic. If x is equal to 0, then this is equal to 0, then this is parabolic. If x is less than 0, then again this becomes this becomes less than 0 and it's an elliptic. So in this case also it could be any of the three. So option D should be the correct answer. If you look at the correct answer, it is indeed option. Does it make sense? Is everything clear up until now? Any questions, anyone? If you have anything in mind, let's discuss it right now. Okay. Please don't hesitate. That's what I'm trying to say. Anyway, we will keep moving on. We will move on to question number 7 of today's session, which is asking us to find out the incorrect statement. So there are 4 statements given here. We have to find out the incorrect one. And then once we figure out the correct option, we can select that option from the code. So what are the 4 options? Option A is saying equation is called elliptic if all eigenvalues of A are complex. So matrix A, remember from you know the lectures. So basically this is a matrix of all the coefficients of different terms in an equation. So equation is called elliptic if all eigenvalues of matrix A are complex. Is it option B? Equation is called hyperbolic if all eigenvalues of A are real and distinct. Is it option C? Equation is called parabolic if the eigenvalues of matrix A are real but less than the number of PDEs. But their number. Okay. So not just less, I have to say that their number. Like the number of eigenvalues if they are less than the number of PDEs. Yeah. Or is it option D? None of the above. So among these
Yes,
4 options,
you
there
are
is a
correct.
one wrong option. You have to find that out. Yes, anyone saying anything?
None of the above.
None of the above. Option D. Okay. Okay. So let's give others time also. So let's look for some other responses. Everyone, please try to participate in solving these questions because not only will it help you understand the subject matter better, the final exam would also be in a similar format, same as the
D
assignment.
will be the correct.
Yes, yes, sir. What did you say? Couldn't hear you. Can you come again?
D will be the correct.
D would be correct. Okay. So two responses in favor of D. What about others? What do the others say? I'll read out the statements once again. So there are 4 statements. Statement A says equation is called elliptic if all eigenvalues of matrix A are complex. Option B says equation is called hyperbolic if all eigenvalues of A are real and distinct. Option C says equation is called parabolic if the eigenvalues of A are real but their number is less than the number of PDEs. Or is it option D? None of the above, which uh, implies that all the first 3 statements are correct and there is no incorrect statement among them. Right. Okay. So let's have a look at the correct answer, and it is indeed option D, as many of you correctly said. So what we do is, let's say if we have a set of PDAs, we have let's say dou u dou x a1 dou u dou x plus a2 dou u dou y, no, sorry, a2 dou v dou x plus a3 dou u dou y plus a4 dou v dou y equal to 0. And there is a second equation which is, this doesn't have to be 0. Let's say this is equal to some f1. Then we have 1, 2, 3, 4, and we have 5 dou u dou x plus 6 dou v dou x plus a7 dou u dou y plus a8 dou v dou y equal to some f2. So what we can do, we can compress this set of equations into something like this. So here U matrix is UV and this F matrix is F1, F2. So using these matrices, matrix A and B, we can figure out the mathematical classification of these equations. So what we do is we try to find out the eigenvalues of this. If the eigenvalues are, if all the eigenvalues are complex, then it's elliptic. If all of them are real but distinct, then it's hyperbolic. If all of them are real but less than the number of PDs. What is less than? I mean, as long as the size of A is maintained, you will get that many number of eigenvalues. So if there are n equations, you will get n eigenvalues. But there could be repeated eigenvalues. So the number of unique eigenvalues may be less than the total number of PDEs. That's where this distinction comes in. And if they are less, then that equation is parabolic and not hyperbolic. So as we can see, all these three options, they are correct. And none of these statements are incorrect. So the incorrect one would be the last one, none of the above. Right? Okay. So I'll end the poll. Okay, we have a question in the chat box. Kindly explain domain of influence and domain of dependence and its practical significance. Correct, very good question. So these domains of influence and domains of dependence, these are, so basically, uh, let's say we have two independent variables, x and t, and we are trying to solve for it over here. Characteristic design also. Okay, we will get into that. So let's say this is our domain in x and t. Finding the solution means knowing the values in all, in this entire field, which is called domain, so to say. So in all x and t, we need to know the solutions. So basically, what happens in let's say elliptic equations. In elliptic equations, there is no t, right? With t, it basically approaches an equilibrium and is no longer a function of it. So basically, along any line ranging from x equal to 0 to say some x equal to capital X, if we know all these values, we know the solution. So in cases of elliptic equations, the question of dependence and influence doesn't raise. In let's say parabolic or hyperbolic cases where there is a variation with time, there things could be like this. So someone said to determine discuss the characteristic lines as well. So for now, let's assume these are the two characteristic lines. So I'll call them CL, and this particular point is some t equal to tau, this is the point which we are looking at. So at this point, we have a history, right? So what is the history? So what happened before t equal to tau? So this region, this is called the sorry, this is called the region of influence, and the future of the system, what will happen after this, which can be influenced by the region of influence. This is known as the region of dependence.
Uh, I may be wrong, but is it the opposite? Well, which you have
Is the
shown.
opposite. Let me check. Maybe wrong. Yeah, sorry, I am wrong. So this is called the region of influence, and this one is the region of dependence. Okay, so I got it messed up. I'm explaining. Sorry, and thanks for pointing it out. So basically, what happens? You have a system. Forget about all this. We have a system. So, what is the state of it currently is determined by whatever happened in its past, right? So, if we take human beings, for example, our current state, our current skill set and mindset and all that, that depends on our past, the kinds of lives which we have left, which we have led. So our current state depends on that entire past. So that's why this is called the region of dependence, because the state of the system is depending on whatever happened in this region, what the states were during this region. And the future, so to say, that can be influenced by the current state of the system. So that's why this region is called the region of influence. And as you can see that there are limits in the domain. Uh, like let's say at this point, it can influence only up to here. Let's say some, you know, from some x1 to x2. So there is a limit to it, and that also depends on the behavior of the system itself. So from system to system, it may vary, and so this is how region of influence is determined. So we have another question: characteristic lines also. So by definition, what are characteristic lines? There are multiple definitions of characteristic lines. One of them is said that information travels along them. Right. There is another second definition which tells us that the derivatives of the dependent variables, so derivatives of dependent variables become undefined along these lines. So there is an interesting theory I briefly told you about during the last session, which is called the method of characteristics, which is used to solve different hyperbolic problems. So method of characteristics can be used to solve different kinds of problems, primarily hyperbolic equations. So what it does is that from the first equation, it finds out what the where the characteristic lines are, and then those lines they propagate with time. Using that, they try to find out the final solution of it. I will send you a good link for it. Give me a second. Where did it go? Give me a moment. I'll share the link with you. Then you can go ahead and see it for yourselves. Give me a moment. Here. I'm sharing the link in the chat box. I hope everyone will be able to access that. So this is a resource which you can use to learn a bit about method of characteristics and its practical significance. So at one time, as I told earlier, that space expeditions, those spacecrafts and all that, those were designed initially using method of characteristics when there were no powerful computers to perform CFD and all that to do a detailed study. Method of characteristics actually helped many scientists working on that project. So there is a bit of history associated with it as well. Does that answer your question? Is there any further clarification required? Okay. If not, we will move on. We'll move on to question number 8 of today's session. Yes, Anubhav Gupta. Can you unmute and ask? What are you thinking about? Let me know.
I'm okay, sir.
No, you said no, sir. I thought you didn't understand anything.
I means I have no question more.
Okay, okay. Sorry, my bad. All right, so let's move on to question number 8 of today's session. So we have to find out the correct statement now. Earlier we had to find out an incorrect statement, now an correct one. So here also there are 4 statements. I'll read them out. Statement number 1 says, if components of the characteristic normal are real, then the equation is elliptic. Option B, if the components of the characteristic normal are complex, then the equation is hyperbolic. Option C says, if components of the characteristic normal are real but less than the number of PDEs, the equation is parabolic. Or is it D, all of the above? The poll is live. Once you have figured out the correct option, you can put in your response over there. So read the statements very carefully. If components of the characteristic normal are real, the equation is elliptic. If components of the characteristic normal are complex, the equation is hyperbolic. If components of the characteristic normal are real but less than the number of PDEs, the equation is parabolic. Or is it D, all of the above? So what is the characteristic normal? First of all, just like characteristic lines, there are characteristic surfaces as well. In 2D, there are lines. In 3D, there would be surfaces and so on. And characteristic normal is this vector normal to that characteristic line. So using this characteristic normals also, we can determine the mathematical classification of the system. So their components, this n cap, can be further divided into decomposed into nx I cap plus ny j cap. So these components nx and ny, if they are real, is the equation elliptic. If they are complex, is the equation hyperbolic. Or if they are real but less than the number of PDEs, the equation is parabolic. Which of these? Or is it option D, all of the above? We have a response in the chat box which says option C, and in the poll, okay, in the poll also we have one response in favor of option C. So if we look at the correct answer, it is indeed option C. So very good. So basically, if the components of the characteristic normal are real, then the equation won't be elliptic, but rather be hyperbolic. And similarly, if they are complex, then the equation won't be hyperbolic, but rather be elliptic. And here again, the in option C, if the components of them are real, but their number is less than the number of PDs, or there are repeated, components similar to repeated eigenvalues, analogous to that, then the equation becomes parabolic. Or any one could be zero as well. Any one component could be zero as well. Then also it would be parabolic. Clear? Oh, so we will move on to question number 9 of today's session. So, how would you classify the boundary layer equation for flow over a flat plane? Would you classify it as hyperbolic, elliptic, or parabolic? Or option D, either A or C? So there is one quick response in the chat box saying C, parabolic. Let's see what others say. So how do you write the boundary layer equation for flow over a flat plate? Can anyone help me with it? Boundary layer equation for flow over flat plate. Anyone, don't feel shy. So basically, what are the equations for solving flows? It's Navier-Stokes equations, right? But with some assumptions, we can get rid of some terms and then get a simplified equation, which is known as Prandtl boundary layer theory. Write this in short, BL theory. So what does it tell us? What the equation look like? So in study Navier-Stokes, we have u dou u dou x plus v dou u dou y, right? So this is what we're trying to solve. There is a boundary layer like this. There is a u coming in, free stream u. This is x. This is y. We're trying to solve it within this. So this basically boils down to dou to u dou x square. So in this equation, which term is of the highest order? Highest order term in this equation. Which one is it? Anyone? Okay, tell me the order of this equation. Yes,
Second order
second,
del 2u by
and this is the highest order term, right? So I have a equal to nu, then b equal to 0, c equal to 0, right? So if I try to find out b square minus 4ac, what would it be? 0 square minus 4 into nu into 0. So basically I will get 0. And the correct answer would be then what? Parabolic, right? So if this is 0, we get parabolic equation. So let's have a look at the correct answer. It is option C, parabolic. So in the poll, we have two responses in favor of option C. And okay, in the chat box, someone said C first, then change to B, change to D. But no, it would be C. Okay. So, any questions, anyone? Okay, so then we will move on to last question of today's session. So here is a set of PDs. We are being asked to classify this following set of PDs. So let's have a look at that. How will we do this? So in case of single PDs, there were no issues. We could simply do b square minus 4ac and get it done. If we have set of PDs like this, there are three approaches which we were taught by Professor Dalal in his lectures. So we can use any one of them to do this. So let's see. We can give me a second. So we can first of all compress these kinds of equations into a form similar to this, which we saw earlier. Equal to something, anything. Now, after this, we can say that P is equal to determinant A, Q is equal to this determinant B, and another determinant we need R, which is A1, A2. Let me see what it looks like. Okay, so it looks like A1, B1 into A4, B4 plus A2, A3, B2, B3. But these are, coefficients of the equations. So, and then we find out H equal to R square minus PQ, is it? Or is it 4PQ? 4PQ. And then depending on whether H is less than, equal to, or greater than 0, we will be able to classify. So here, if we try to compare these equations with the general one, so I'll write down the general one once again. So it's a1 dou p dou x plus a2, so okay, instead of p, let's work with u over here. So u dx dy dou u dou y plus a4 dou v dou y equal to 0. Then second equation, no, sorry, not 0, some C1 or A5. Then B2 we can have A dou x, sorry, B1. Then B2 dou V dou x plus B3 dou U dou Y plus B4 dou V dou Y equal to some B5. So A is basically A1, A2, B1, B2. And matrix B is A3, A4, B3, B4. Correct. Right. So comparing this, I'll try to. So comparing this over here, we can have A equal to okay. So basically, there's a mistake here. These won't be fees. So I'll write this out. It's not working. Anyway, let me reframe the question. So I have A dou phi dou x plus B dou psi dou y equal to some f1, and then I have C dou phi. What did I have over here? Dou phi dou x dou phi dou y. Then I have C dou psi dou x plus D dou phi dou y equal to some f1. Now comparing it with those earlier equations, let's see if I can include them. Oh, the slideshow went away. Give me a moment. I'll reshare. Slides are up, right? You can see them. Can anyone confirm that they are being able to view the slides? Yes, right? Okay, good. Okay, so this is the equation that we have, and in the bottom we can see that these are the general equations where u equal to u, right? So what would be the matrix A in our case? This is our case. This is what you focus on and try to use this analogy to figure out the components of this matrix. So what would be the component of A? Can someone please help me along? So here our U would be phi psi like this. So what would A be? The components of A, what would they be? A1, dou U dou x. So here instead of U we have phi. So dou phi dou x is over here. Sorry. So dou phi dou x is over here and its component is A. So we will take that. Then A2 is component of dou v dou x. Do we have a dou v dou x here? So do psi do x, if it was present there, it would have been there, but it's not there, so it could be 0. Similarly, b1 of do u do x, or in our case do phi do x in the second equation. In the second equation it isn't there, so it would be 0. Then let's come to b2. B2 would mean the coefficient of do v do x, or do psi do x, which we have here, and its component is C. So this is our A matrix. Correct? Did I make any mistake over here? Please correct me if I'm making any mistakes. Now let's go to matrix B. What would be the components? A3, A4. A3 means do u do y. In our case, do phi do y. Do phi do y in the first equation. It isn't there, so 0. Then we need A4, which is do v do y, or in our case do psi do y, which we have, and is equal to B. Then we come to this second equation where B3 is there, and B3 means do u do y. So in an equivalent case, we would need do u do y, right? So in equivalent case, do psi do y we will need. And it's indeed here, and its component is D, and the other one would be 0. So we have matrices A and B. Now if we try to find P and Q, P would be the determinant of this. A0, sorry, A0, 0C. So that would be AC. Similarly, Q would be equal to determinant of B. So 0, B, B 0. So this would be 0 minus BD. Correct. And let's figure out R quickly. R would be A1, A4, B1, B4. What is our A1 over here? A1 is A. A4 would be B. Then B1. B1 would be 0. B4 would also be 0. Plus A2, A3. Here A2 is 0. A3 is 0. And B3, B4. B3 we have D. And sorry, no, B2, B3. So B2 we have C. And the other one, which is B3, B3 is D. So, but unfortunately, both these are 0 plus 0. So, R equal to 0. Now, if we try to find out this, H equal to R square minus 4PQ. So, H equal to R square, R is 0 square, minus 4 multiplied by P, which is AC, into Q, which is minus BD. We have H equal to minus 4, sorry, no, minus would become plus. So this would be A, B, C, D, and it would ultimately depend on the signs of these coefficients A, B, C, and D. That's how we would be finally able to determine H and then classify the original equation, set of equations. So this is one of the approaches in which we can do this. Any questions on this? So this brings us to the end of today's session. Thank you all for being so enthusiastic regarding it. I hope to see you guys in the upcoming sessions as well. And all these sessions are being recorded and being uploaded in YouTube. I'll share the channel with you guys. So if you miss any class, you can go back over there and have a look. And you can look into the past videos as well. Plus, in future, if you miss any, you can always go there. So give me a second. I'll share the channel with you guys. So I shared a link in the chat box. You can open that link. It leads you to a channel, and you can subscribe that channel for the future videos. Okay. So if there is nothing else, then thank you. It's been a great session. See you next week. Okay. Bye.
Thank you, sir.
Thank you.
Thank you.